Now that you've watched the content video on Chapter 2, Samples C and D, let's look at Samples C and D sample problems so that you can finish your practice problems on sections C and D. Once again, before we get started, once you're done with your work, look at the end of the textbook for the correct answers to the odd problems. All right, sample C. This is dealing with displacement and a constant acceleration. So now we're getting into these kinematic equations. Let's read through the problem. A racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its parachute and braking system and comes to rest 5.5 seconds later. Find the distance that the car travels during braking. So looking at this, real quickly here, I can see that some of our givens are not going to be numbers. They're going to be in words. But let's start over again and see the first one we come across. It says a racing car reaches a speed of 42 meters per second. So that would be an initial velocity. It then begins a uniform negative acceleration and comes to rest 5.5 seconds later. So what would that mean your VF is, guys? Well, it came to rest, so 0 meters per second in a time of 5.5 seconds. Okay, so from that, our unknown is find the distance the car travels during braking. Well, really, the book should say displacement, not distance, because I want you to do delta x and not delta d for distance. Let's look at delta x. What units would this be solved for in? Looking at your velocities, you'll know that it'll be solved for in meters. Okay, time for original equation. Check out what you have and what you don't have. There's no acceleration written here, okay, because it's a constant acceleration. So which kinematic does not have the a in it? That kinematic should be delta x equals 1/2 quantity vi plus vf times delta t. Oh, looky, we do not need to rearrange. That's great. So we could just go ahead and plug right in. But time out, double check those units on your givens. Are they good to go, or do you need to convert any of them over? Well, everything's in meters per seconds or just seconds, so we are good to go on this. Let's go ahead and plug in. Get your calculators out as well. So we have 1/2 times the quantity of 42 minus 0 times 5.5. So in your calculators, 0.5 times 42 times 5.5 equals. Look at your calculator answer. What is it? My calculator came out to 115.5. All right, checking over here at your givens again. The least number of sig figs that are in your givens is 2 sig figs. So let's look at this 5. What's the 5 going to do to the 1? Does it round it up or keep it the same? Your delta x becomes 120 meters. Hey, Miss Arter, grade this one. Don't forget to box it. That'll be my heads up with my eyes to understand if I'm giving you points or not. Make sure you're applying all steps of the guess method when working on your sample and practice problems and targeted homework and challenge problems. Okay, so for practice problem C, you're going to pretty much just be using this kinematic equation. But once again, guys, I understand this is a little frustrating stuff here. The way that I always try to figure out when I'm solving through on the problems or making up new problems is what variable is missing? Is initial velocity missing? Is final velocity missing? Is time missing? Is acceleration missing? Or is displacement missing? So whichever variable is missing, you should then be able to figure out which kinematic you can correctly apply to these problems. All right, good luck with these ones. Real quickly here, practice problem C, number 1 has 1 answer, 2 has 1 answer, 3 has 1 answer, 4 has 1 answer, and you'll need to convert some givens before you can use the equation on number 4. Convert givens, units, before you can solve into an equation. And that is all, just your 4 questions there. All right, guys, let's move on to D. Sample problem D, velocity and displacement with a constant acceleration. So this problem says a plane starting at rest, let's just stop right there, one end of a runway undergoes a uniform acceleration, A, 4.8 meters per second squared, don't forget that squared, for 15 seconds before takeoff. What is its speed at takeoff? And how long, time, must the runway be, how long must the runway be for the plane to take off? That is not time, that would be displacement in meters. Okay, let's solve for the first one here. How fast? So that would be a final velocity. Look at your final velocity equation here. For your final velocity equation, we only have acceleration and time that we can really work with, but you do know one that has initial velocity in there. VI plus A times delta T. It doesn't need rearranged because the variable you're trying to solve for is already isolated. So 0 plus 4.8 times 15. Please put that in your calculators at this time, guys. 4.8 times 15. What answer did you get? Your calculator should say 72. Looking back at your givens, you do only want 2 sig figs, so therefore final velocity is 72 meters per second. Box it to indicate this is my final answer. All right, next one here. It says, how long must the runway be? So that's obviously a delta x. You have a whole slew of variables here now, guys. You have pretty much everything that you can consider. And the kinematic that considers everything would be VI times delta t plus 1/2 A delta t squared. So from that, good. We don't need to rearrange it, and I highly suggest, since this is pretty brand new, you solve for the first quantity and get an answer. You solve for the second quantity and get an answer, and then you add them together. Okay, so let's kind of adopt that method until we feel totally cool and content with the way these problems are going. All right, so your VI was 0, and your time is 15, plus 1/2. Your acceleration was 4.8, and your time was 15 squared. Please, please, please note, it is just the time variable. It is not the entity of A times T squared. It is A times T squared. Makes sense? Please be cautious when you're putting that into your calculator. Check out how simple this is. Guys, what's 0 times anything? 0, right? So all we pretty much have to be concerned with is 15 squared times 4.8 times 0.5. Put that in your calculator right now, please. 15 squared times 4.8 times 0.5. Your calculator should read 540. Oh, this is getting too simple. 540 only has 2 sig figs. Therefore, your final answer, 540 meters. Okay, so these are the 2 equations that you're going to want to use for the for the practice D problems. Looking at your answers, that means that you're going to have 2 answers for all of these problems. Number 1, you're going to have a VF equals and a delta X equals. So 2 answers for number 1. Number 2, VF equals and delta X equals. Number 3, VF equals and delta X equals. And then number 4 switches it up a little bit, so you actually do have to rearrange the equation. You're still going to start off with your VF equals VI plus A times delta T, but you're going to rearrange it for delta T equals. Also, continue to use that delta X equation and solve for delta X. So 1, 2, 3, and 4 all have 2 answers, and once again, the odd answers are in the back of your textbook. Please show the guess method on each of these problems so that we can give you full credit when we check the practice problems in class.